Hi, welcome to lecture session 4 of Database Management Systems course, and this is dedicated for relational data model concepts and relational constraints. We talk about what is relational data model, what are the basic features of relational model, relational constraints, and how do we represent the schemas in relational model. And relational data model was introduced by a gentleman called Edgar Codd in 1970s at IBM Labs. He proposed relational data model. It is a representational or implementation data model, like how we use ER model, that is for conceptual model. This is relational model, it is an implementation data model, and each database management system will have its specific implementation data model, and relational data model is one among them. Database management systems like Oracle, MySQL, Ingress, they have adopted, they are according to this model, relational model. We represent in this relational model, we represent a database as collection of relations, but we should be very careful about the notion of relation here, and it is certainly different from the notion of relationship used in ER modeling. There in ER modeling, relationship means association between two entity types, whereas here in this, a relation means it is a construct which is used to represent data in relational model. Relation is the main construct for, it is a basic construct for representing data in relational model. Every relation consists of a relation schema and a relation instance. As we have seen, each relation will have a relation schema and a relation instance associated with that. The relation schema can be represented like this. Employee is the name of the relation, and these are the attributes or fields of the relation. This is called as the schema for the relation, or it can be simply specified like this. Here in this, along with the attribute, we have also specified the data type for the field or attribute, but for the sake of simplicity or brevity, we can avoid that data type, and then we can simply represent a relation schema like this also, which is valid. Now coming to the relation instance, the schema is going to define the structure for the rows or the instances of that relation. Then now this can be considered as a relation instance for employee relation. For employee relation, this is the schema, and this is going to be the instance. Instance of a relation at any given point of time contains a set of valid rows or tuples or records for that relation. Okay, so if you carefully observe, there are 3 records in this, there are 3 tuples. Relation instance can be seen as a table of rows, and each row is going to obey the structure that has been defined or specified for that relation in relation schema. How many rows are there? In this example, there are 3 rows. Each row is called as a tuple, and then if you carefully observe, it is a ordered list of values, and then if you look at the structure of each of these records, it contains 3 values for 3 of the attributes or fields that has been specified for the relation employee in relation schema specified on that. This is a relation instance, and this is called as a relation schema. Relation schema is denoted here like this. So, or it is a general form. R is the name of the relation, and then these are the list of attributes. The number of columns in a relation is known as degree or arity of the relation. In the previous example, what we have seen with the employee relation, the arity or degree of the relation is 3, since it had 3 columns or 3 fields. Relation instance or a relation state, both are same. Relation instance or relation state, small r of caps R. Caps R is nothing but the relation schema, and small r, which is known as the relation instance, can be thought of as a table, and each row in the table represents a collection of related data. Each row contains facts about some entity of some entity type. In the previous example, the entity type that was captured in that relation was employee, and then each row was revealing some facts about some entity of type employee, and then relation schema is going to be like this. R is equals to, it is set of attributes. Then small r of R, which indicates instance, relation instance of caps R, is a set of n tuples of R. So what is small r? Small r is set of tuples T1, T2, T3, Tn, like this. And whereas R, if you carefully observe, this is not a tuple, rather it is an ordered list of attribute names or fields. That is the difference between this representation, that is curly brace representation, and this parenthesis representation. If it is a curly brace representation, it is a set. That means whenever it is a set, the ordering of the elements in a set is not significant, whereas if it is a list or the order is very significant. That is why the ordering of attributes in a relation schema is very significant, whereas ordering of tuples for a relation or relation instance is not significant. From now onwards, we will be using the term relation and then relation instance interchangeably for the sake of convenience. Small r is an instance of capital R. R is what? Relation schema, and each T, here T1, T2, T3 up to Tn, each T is a tuple and is a ordered list of values. It is a ordered list. So ordering is very important for values for a tuple. And small t is equals to what? It is ordered list of values v1, v2, vn up to vn, whereas vi is an element of domain ai. So suppose if I take, how many attributes are there for R? 1, 2, 3. Let us assume that there is a relation R which has attributes a, b and c, and then if I take a tuple which is an ordered list of values, suppose if it is 10 and then a and then 25, something like this, this is from the domain of A, and this value should be from the domain of B, and then this value should be from the domain of C. What is the domain of an attribute? The possible set of values for an attribute or field is called as its domain. For example, if you take the age of a person, what could be the domain? It must be an integer, and the values, the valid, if you look at the meaning and then semantically correct data for age of any person, then it should be between 1 and 100 or 110 or something like that. It cannot be like 1055 or something like that, which is absurd. So that's why all possible set of values that become the domain for that particular attribute or the field. Entities of each type or set are stored as rows in a single relation. Suppose if you go back to the database representation at conceptual level using ER model, what entity types we had? Let us assume that we have employee entity type, and then we have department entity type. Then all the instances that belong to, all the entities that belong to employee type will go into one relation, and then all the instances, all the entities of entity type department will go into another relation. So that's why we have two relations here in this case. Normally entities of each type are stored as rows in a single relation. Hence in general a relation corresponds to a single entity type in ER model or ER diagram. In some cases a relationship between two entities can have some specific attributes which can be captured in a relation or table. That we will see when we talk about how to translate a ER model or ER schema into relational schema. A row is called as a tuple. That's what we have learnt just now. The column of the table represents attributes of that particular entity set. Suppose if you take employee entity type, then you have employee ID and then employee name, something like this. Then I have a relation. I define a relation to store the entities of the information about employees. Then first attribute, all the attributes of the entity type, they become columns or fields in that relation schema. So first one is going to be EID, that is first field or attribute of the relation, and second one is going to be the name, so on and so forth. Then a row is called as a tuple. The column header is called as an attribute or a field. Data type or format of an attribute, meaning that what is the format of data for the attribute. For example, name is a character string, and then age is a numeric value, and some employee ID or student code, student ID could be alphanumeric value, so on and so forth. So every field or attribute is specified by a data format, and then which specifies or which in turn gives the set of possible values for that particular attribute. This is called as the domain of the attribute. Values that can appear in a column, under a column for any row, is called as the domain of that particular attribute. Here the relational database schema is given. S is equals to, this is about relational database, not about the relation. How do I represent relations? Let us assume that R1 is a relation, and then which has attributes A, B and C. R2 is a relation which has attributes X, Y and Z, something like this. Now all these relations put together, suppose if I have if I am capturing information for a company, I have employee relation which has some attributes, and then I have department relation, and then I have project relation, wherein put together all these things are going to capture a valid information or meaningful information about the activities of the company. So that is why this is called as the database. The set of logically related relations are called as the database, or it is called as the database. And then in this company database, here in this example, I have employee relation, department relation and then project relation. Then we know how to represent a relation schema. This is how we represent a relation schema. This is the name of the relation, these are the attributes of the relation. Now how do I represent the schema of a database? Database is nothing but collection of some relations, related relations. Okay. So S is going to here, this is how we represent the database schema. S is going to be the name of the database, and then R1 is the relation, so R2 is also a relation, like that, and then it is nothing but set of relations that comprise of or that makes a database schema. This is how we can represent the schema of a database. Name of the database, and then these are the set of relations that are part of the database. Attribute A of a relation R is accessed by the notation called as dot notation. It is like this. R is, let us assume that there is a relation called R and which has attributes A, B and C, and if I want to refer to the attribute A of relation R, how can I do that? Using the dot notation. That is, if I say R dot A, it indicates the attribute A of relation R. Suppose if I have some other relation called P and it also has A, X and then Y, then if I say P dot A, then I am referring to the attribute A of relation P. So this is how we can refer to the attributes of a relation. So this is the schema of a relation. The name of the relation is student and it contains three attributes: name, age and branch, and student dot age means I am referring to the age attribute of student relation. Now let us look at a quick summary of the characteristics of the relation. And if you look at the relation, the ordering of tuples is not significant. Okay. Suppose if I take an employee relation, here the employee ID is there and then employee name and then age, these are the attributes. I have three tuples, these are the tuples. And relation instance R, if I call this instance as R of type employee, okay, then it contains the tuples T1, T2, T3. If I give names to each of the tuples, T1 is nothing but this, T2 is this and then T3 is going to be this, then the ordering of these tuples in a given relation instance is not going to be significant. I already told that I will be using the term instance, relation instance and relation interchangeably. So that is why the ordering of these tuples is not going to be significant in this, and it can be anything. So this third tuple can come first and then first can go to the last, so on and so forth. But ordering of the values in a tuple is very, very significant. If you look at a tuple, suppose in our previous example, if you take this first tuple, what is the ordering of the values? 101, Raj, 28. So this is an ordered list of values. That is why the swapping, or they cannot change, the order cannot change. If you change the order, suppose if I look at it like this, Raj, 101 and 28, and it does not make much sense, because this tuple, which is a tuple based on the relation schema employee, the relation, this each and every tuple or each and every row or record must obey the structure that has been specified for the relation in this relation schema for employee relation. So what does the structure says? First value should be employee ID, which is should be of type integer. Second value should represent name of the employee, and which should be of type string. Third should be age, which is of type integer. And in this case, if you look at this exactly matches, or it obeys the rules laid down at the schema of the relation. And then if you look at this, first one is integer, second one is going to be string, and third one is going to be an integer again. And if you look at this, if I am swapping, if I am changing the order, first one actually according to the structure of the relation schema, the first value should be of type integer, but I am violating that here. It is of type string, which is not correct. And second one should be integer, it is integer, but actually it need to be a string type, which I am violating here. So that's why the ordering of values in a tuple is very, very significant, whereas ordering of tuples in a relation instance or a relation is not significant. And values in a tuple under each column must be atomic. That means simple and then single. That means if you have a row under this like this, and then I cannot have value 1 and then value 2 and value 3 like this. If such is the case, this becomes a multi-valued attribute. Multi-valued attributes are not possible in relational model. Under any column for any row, I cannot store multiple values under a column for any row. It is not possible. Multi-valued attributes are not possible. And then it should be simple, meaning that what? It should not be complex. That means I cannot store under any column for any row, I cannot store a complex or composite object as a value. That violates the principles or rules of relational model. So we should be very, very careful about that. These are the basic features or characteristics of relation model. And one important thing here is, after collecting the requirements, we will understand what exactly need to be stored in the database. Then we will come out with a semantic level conceptual schema in terms of entities and their relationships using ER modeling. Once you are done with that, you are free to choose whatever specific data model you want for implementation. You can choose relational data model, you can choose object data model, network model, so on and so forth. So that's why up to ER modeling, it is common for all implementations. Once you are done with your ER modeling, we should decide upon what implementation model we need to select or go with for the implementation of the database. If we are going with the relational model, then we need to translate this ER model or ER schema, conceptual level schema, which has been designed using ER modeling, should be translated into relational database schema, which is described in terms of relations, like what we have just now seen in this previous slides. So that's why up to this conceptual level modeling, it is independent of any implementation model. Once we are done with the ER modeling, then we need to choose a specific implementation model, and then we need to translate the conceptual schema into DBMS specific data model like relational data model. Then this is an example of an instance of relation student. This is the name of the relation, these are the attributes of the relation, and these are the valid tuples. And if you carefully observe the tuples of this instance, they perfectly obey the rules that have been laid down while defining the structure for the relation student. So that's why these are the valid tuples. This particular relation instance, I can give some name to that. I can call it as smallest of student. What is this? Student is the relation. So this is an instance, this is a relation schema, then which contains the 5 tuples T1, T2 up to T5. T1 is this one, T2 is this one, like this. So ordering of tuples at this in a point of time, this particular relation instance contains 5 tuples, and a later point of time, as and when it is required, you may delete some tuples or we may add some tuples to the instance. So that's why every relation in relational model will contain a relation schema and a relation instance. A relation instance is nothing but a collection of valid tuples or rows for that particular relation. Now we need to be very, very careful about the terminology that is being used in relational model, and the informal terminology is given in the first column and next we have given formal terminology that need to be terms that need to be used when we are talking about relational model. The informal term is table, that we call it as a relation or relation instance. We will be using both the terms interchangeably. Column header, which is called as a attribute. All possible column values or all possible set of all possible values under a column is called as domain of that particular field or column or attribute. Informally we call the rows in a table, here in relational data model we call them as, formally we call them as tuples. Then table definition is called as relation schema, relational schema or schema of a relation, and populated table is called as instance of a relation, instance of the relation or state of the relation. Okay. Then very important discussion is about the constraints that can be enforced on the data that is being stored in the relational databases. Constraints or restrictions. What are constraints? Basically they are restrictions that are imposed on the data of a relation. And while we store data in databases in relational data model, we need to make sure that that data should be of a particular format, or it should follow certain rules. All these restrictions are specified in the form of constraints. We call them as integrity constraints, otherwise we can call them as constraints. These are the rules. First constraint is domain level constraints, formatting of the data and other semantic related constraints. Second is entity integrity constraint, and third one is referential integrity constraint. The fourth constraint we can enforce is dependencies. What is domain level constraints? Domain means what? The set of possible values under a column or a field is known as the domain of that particular attribute. Suppose if I have employee table, I have employee ID and then name and then age. Let us assume that first one should be of type integer, second one is of type string, and third one is of type again integer. So this is format. What should be the format for each of the columns? That is also specified under domain level constraints as domain level constraints for the relation. At the same time, we need to take care of semantic level constraints also for the values that go under columns for any row of the relation. For example, if I am entering some values for the instance in an instance of employee relation, can I enter ABC here? Is it possible? First value, can it be ABC? It is not possible because it is violating the format that has been specified for the first row, first field or attribute. Okay, if I am entering something here, I can also specify that whether that value can take null value or not. Can it be null or not? That can also be specified. And at the same time, we can also check whether a value under a given column for any row need to be within a given range or not. For example, if you take the age attribute, the format should be of type integer and the value should be between 1 and, let us assume that the maximum age can be 120 according to the business rule of the company, then the value whatever I enter for any row under the column age of employee relation for any tuple, it should be ranging between 1 and 120. So these are known as semantic level constraints that can be enforced on the values under any column or attribute that can be entered for any row of a relation. And then we have entity level integrity constraints. Under this we can specify primary key and then unique key. Let us take the example of employee relation. Here I have 3 rows, 1, 2 and 3. The company rule says that the employee ID should be unique and the rows or the tuples of a relation should be identified, uniquely identified, unique identification, uniquely identified based on the value under the column employee ID. So this becomes primary key, and we can specify this kind of entity level constraint in relational model in the form of primary key. That is possible. That means if you take any 2 rows, they will definitely, the value under the column EID will not be same for any 2 rows. Suppose if I am inserting a 4th column for the relation instance for employee, then if I try to insert 110, some name is A and then age is 32, this gives an error because I am violating the primary key constraint that has been specified on the relation, and according to this it clearly says that no two tuples or rows can have same value under the column which has been specified as the primary key. That is the first entity level constraint we can specify. The next one is uniqueness constraint. That means apart from the primary key, by default all primary keys are unique, values under primary key are unique, and if the requirement is such that you may need to specify or you may need to have one more attribute, and which is also whose values need to be unique for different tuples, then we can specify that apart from the primary key we can have some other attributes to act to be unique. Suppose if I have a social security number SSN and that need to be captured in the database for a company for employees, then if I specify that the attribute SSN is unique, meaning that no two rows, like what we have seen with the primary key, no two rows will have same value under the column under this particular attribute, that is social security number. And if you try to enter multiple columns or more than multiple rows with same value under this column, that definitely violates the uniqueness constraint, that gives you an error message. Then we have referential integrity constraints. These are implemented in the form of foreign keys in relational data model. After the slides we will have detailed discussion about this referential integrity constraints. And then we have dependencies. Functional dependency, what attribute? It is nothing but it says that what attributes values define the values of other attributes is called as dependency. These concepts are heavily used in the process of database design or normalization. So that is why we will defer the discussion about these dependencies as of now, and then we will take up the detailed discussion when we actually talk about the database design process, that is normalization. Now we will discuss in detail about referential integrity, how it can be enforced and what is the meaning of it. In relational data model it is implemented as foreign keys. The referential integrity constraint is specified between two relations and is used to maintain the consistency among the tuples of two relations. It is a very important and then complex feature of relational data model, and this helps us in maintaining the consistency in the database. Suppose let us consider two relations, R1, this is the first relation, the name of the relation is R1 and it has the attributes A, B and C. Let us assume that A is the primary key. This is the relation schema for R1. Similarly, I have second relation whose name is R2 and which has attributes P, Q and R, and P is the primary key. Now I can specify a referential integrity constraint in the form of foreign key, that is I can make the attribute C in R1, relation R1 to be foreign key which refers to the primary key of the relation R2. That means C refers to P. C in R1 refers to P in R2. What is the meaning of this? The FK attribute R1 has the same, meaning that what? The foreign key attribute C in R1 has the same domain as the primary key attribute of R2, that is P. The attribute C in R1 is said to reference the attribute P in R2. The value of foreign key in a tuple T of R1 either occurs as a value under P in R2 for some tuple or it should be null. Suppose let us assume that I am going to have some tuples or rows for R1 and A can be anything. Let us assume that it has some domain, and here for P it is T 20 and then like this, and then if I am entering a tuple for R1 under the column C, whatever value I am inserting for a tuple, either it must be existent under the column P in R2 or it should be null, nothing else is possible. And R1 is known as a referencing relation in this example, which is dependent on what? R2 is not dependent on R1, but the column values of R1 are certainly dependent on column values of R2. So that is why we say that R1 is a referencing relation and R2 is known as referenced relation. Constraints can be specified while defining the structure of the table or relation, or they can be specified in the form of triggers that we will discuss later. Let us have a look at this to have a better idea about referential integrity constraints in the form of foreign keys. Let us assume that I have employee relation which has employee ID, name, age and department number attributes, and this is a specific and we have department relation which has dnum, dname and then dlocation. Since this is how we can specify the relation schema in relational data model. Okay, since this attribute is underlined, we assume that it indicates that is the primary key of the table employee. What is the primary key of the table department? It is dnum. Now I make dno attribute of employee table or relation a foreign key, and then which references dnum of department table, meaning that what? Employee is a referencing table and then department is a referenced table, and if at all I am entering some value under this, and if you look at this, this is a valid relational instance for relation employee, and each row has 4 columns, and the column values, they obey the format that has been specified for the employee relation in the schema. So now according to this foreign key constraint, what happens, and according to this this is a primary key, according to this primary key constraint, what should be there? No two tuples or no two rows can have same value. Yes, it is maintained here, so that is followed, strictly followed, so that is why there is no problem as far as primary key constraint is concerned, and in this also this is the primary key, and I can see no two rows having same value under the primary key column, so there is no problem. And now further what I have done is I have specified the d number as the foreign key in employee table which is referencing or referring to the department dnum attribute. What does it say? If I am having an tuple or row in relation employee, the value under the foreign key column must either existent in the reference table under the specific corresponding column, or it should be null. And if you look at the dnum value for tuple 1, yes, it is 10 and it is there in department table under the primary key dnum, and 20 it is there is no problem. This 10 it is there, so there is no problem. So all these tuples under the column dno, which is a foreign key, they have values which are existent or which are seen under the column dnum in department table. So I am obeying the referential integrity constraint that has been specified on employee table, between employee table and then department table, otherwise relation. Suppose if I try to insert one more row with 151, there is no problem, and I have name A and age is 42, and if I say the department number is equals to 40, this violates referential integrity constraints. You see, I am going to maintain the integrity, that means correctness of the database. Is it possible to have an employee who is working with some department which is not at all there in the company, which is absurd? So that is why this referential integrity constraint is going to put a check on that. So if I maintain a foreign key, specify a referential integrity constraint, this is going to take care of that. Since the value under this column, which is a foreign key in employee table, is not existent under the column dnum, which is a referenced column which is referenced by employee table, it is invalid. This will give you some error. And suppose if I am inserting something like 160 whose name is B, age is 42, and then it is null, it is valid because the value under this foreign key column or field, it should be either existent in the referenced table or it can be null, so it is valid. And then if I try to insert something with 111, name is K and something like this, what kind of error it can throw? It definitely throws the primary key constraint violation error, because already there exists an employee with employee ID 111, so that is why it is a clear violation of primary key constraint that has been specified on the relation employee. All these constraints we can specify them while defining the structure of the table in our SQL. Okay, that we will see at later point of time. All these things can be specified, but certain constraints, that is checking the range of value under a column, all such things can be checked using, that can be specified using triggers. Now this is how we can specify the schema, relational schema. This is how we can represent that diagrammatically. Whatever we have seen in the ER diagram. So this is employee relation, these are the attributes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, it has 10 attributes. This is the schema for employee relation. Since this particular attribute is underlined, it indicates that that is the primary key of the relation employee. Then we have department relation, and D number is the primary key. Then we have department location, wherein both the attributes, department location means this captures the information about what department is located at what location, and in fact I could have included the D location here itself, but the situation is such that the department, a single department may be located at multiple locations. So in such case I cannot capture that as a column, the location of a department as a column in department relation, which is not possible. That is why a separate relation or table has been designed, and wherein it contains two attributes, department number and the location of the department. And what can become the primary key of the table? And if you look at that, department number and then department location, and it says, the company rule says that same department can be located at more than one place. Suppose department D1 at Hyderabad, and then department D1 at Chennai, and then department D2, that is at a same city, at same place, more than one department may be located. D2 is also available at Chennai. So in this specific case, what can happen? Well, I cannot make D number as primary key, because multiple rows have same value under this particular column or field, so it cannot become a primary key. Similarly, I cannot make D location as primary key, because more than one column, here in this case row 2 and then row 3, they have same value, that is Chennai, under the second column. So that is why no single column can become primary key. So that is why both put together, if you carefully observe, if you collectively take the combination of these two values, no two rows can have same value for the combined value for these two columns. So that is why these become the combination of D number and D location, it becomes the primary key of the table. That is why both of them are underlined. That is how we can specify the primary keys in a relation. Now coming to the project table, it has P name, P number, P location, and then D num. Of course P number is the primary key, and then works on, which is going to capture. And this particular database schema, this is called as a database schema, because it is a collection of relation schemas. A set of relation schemas is called as a database schema. What database it is? It is company database. For this, the ER modeling, ER model or ER diagram we have seen in the previous class. So here the works on relation is going to capture information about what employee is working on what project and for how many hours. The rule says that same employee can work on more than one project, and then same project can work on more than one, one project can have more than one employee. In that case, what can become primary key? ESSN alone cannot become primary key, because multiple rows will have same value under ESSN column. Similarly, P number alone cannot become the primary key. Then what becomes primary key? Put together collectively ESSN comma PNO can become the primary key of the table. Now the dependent, and in our ER diagram, dependent was a weak entity. It was a weak entity, and unique identification to these dependent entities was possible only when it is each of the entity in the weak entity is associated with the owner entity. And in our example, what was the owner entity? That is a strong entity. The entities which have primary key or keys are called as strong entities, and the entities, entity types which do not have a key are called as weak entities. Now this dependent weak entity is always associated with the strong entity, that is employee. Every dependent is dependent on some employee. So that is why here the ESSN is also captured, and then dependent name is there, and other attributes of the dependent are available. And then what becomes primary key here? ESSN alone cannot become primary key, because same employee can have multiple dependents, and then dependent name cannot become primary key, because multiple employees can have dependents with same name. So put together, the company rule says that employee can have dependents with same name. So according to that, if I put together the ESSN and the dependent name together, it is going to act like a primary key for the table. Then relational schema representation with foreign keys. In the previous slide, we have seen relation schemas without indication about the foreign keys, whereas if you carefully observe in the previous slide, here D number is a foreign key which refers to the D number of the department table, and similarly PNO here is a foreign key which is pointing to P number here, and then ESSN is a foreign key which refers to this, and similarly ESSN here is a foreign key which refers to this, and in this particular slide it is not captured. And now in the next slide, here all the foreign key representations are given here. You see here D number is a foreign key pointing to D number here, and ESSN points to SSN of the employee table, PNO points to this, and then DNUM, which is the controlling department for the project, is a foreign key which is pointing to D number, and then DNO in employee relation, which indicates the employee is working with which department, is a foreign key which is referring to the D number of the department table. And then here there is a unary relation, that is super SSN for a given employee. Who is the supervisor? That is indicated by super SSN. So it is again this super SSN is an SSN of some other employee who is acting like a supervisor for the given employee. So it is a unary relation, and then this definitely refers to the SSN of the same table. This is about how to represent the foreign keys in diagrammatic representation of relational database schema. Now, having these kind of constraints which can be specified on the relations, we need to be careful about things. That is, we need to be careful about when we insert data or delete data or update data, we need to be careful about the constraints. And what kind of constraints we have seen so far in this? We have seen the domain level constraints, which talks about the formatting, null values and range, and then entity level integrity constraints, which talks about the primary key and then which talks about the unique key. Then we have referential integrity constraint, which is implemented in the form of foreign key. Now the following table is going to indicate the constraints need to be taken care while performing certain operations on relations. Let us assume that there is a relation and we need to insert, there are some relations in a database schema. When we are inserting a new tuple or new row into the table, we need to be careful about what kind of constraints. We need to be careful about the domain, because whenever you insert some values, that should match the specifications of the data type that has been specified in that relation schema. That's why we need to take care about the formatting, we need to take care about domain, we need to take care about null or not null. And at the same time, when you insert a new tuple, every relation in relational model will have a primary key, and then we need to be careful about the primary key constraints. We should not violate that. And at the same time, some relations may have additional constraints in entity level integrity constraints, that is uniqueness constraint may be there. We need to be careful about that. For example, the social security number for employee relation, and when inserting a new tuple or new row into the table, we need to be very careful about that. Then at the same time, when we have two different tables, and then where one table is referring to another table under for some foreign key column, then we need to be careful about foreign key constraint also. That means when we insert a new tuple into the table, we should be very careful about domain level constraints, entity level constraints, and then referential integrity level constraints. Then what about the deleting a tuple? When we try to delete a tuple, we don't have to take care of domain level constraints. There is no problem with respect to entity level constraints. The only thing is, if a table from where you are deleting a tuple is being referenced by some other table or tuples in some other table which have foreign keys referring to this table, then certainly you need to worry about this foreign key constraint. If you delete a tuple here, then automatically there will be certain tuples in reference table which will remain dangling. So that's why you should be very careful about that, and we don't have to worry about the domain level and then entity level constraints. Then coming to updates, when we perform update operations, and that means what? You need to change the values under certain columns, some columns of some relation in a table or a table. So we need to be careful about domain level constraints, because when you change the value, suppose the employee ID I am changing it from 1012 to something else, ABC, something like this. So domain, I am violating the domain level constraint, and in the tuple the old value under employee ID column was 101. Now I am trying to making it to ABC, and according to the schema specification the employee ID data format should be integer, but after modification I am going to change that to ABC, which is of type string. So it is a clear violation of the domain level constraint. At the same time, for some columns null values are possible, and then some columns it is not possible, that need to be taken care. At the same time, when I am updating something, I need to take care of the primary key also. Suppose for employee table, when I am updating the value 101 for some employee and then making it to something else 112, something like this, and if that value is already there for some other employee, then I am clearly violating the primary key constraint. Similarly, we need to take care of uniqueness constraint. At the same time, foreign key constraint also need to be taken care, because the value you are going to change in the relation may be referring to some value in some other relation under some column, okay, which is referenced by this table in which you are going to make some changes or modifications to some rows or tuples. We need to be careful about that. We will have a look at what actions need to be taken when foreign key is set between two tables, and when we perform operations like update, insert and delete on either dependent table or on the reference table. And suppose if I have R1, so in this case R1 and R2 are there. R1 has a foreign key in the form of C, which is pointing to P, which is a column under R2. Then this is a referencing relation, this is called as a referenced relation, and C is a foreign key. Now let us have a look at this. If we insert a tuple in R1 where the value for C is not in P of R2, then what should we do? We should not allow it. Otherwise, if a tuple in R2 is being deleted, then what will happen? It is possible that some tuples in R1 under the column C, they may be dependent on this tuple which you are going to delete in R2. In that case, what action need to be performed? First thing is cascade. That means when you delete a parent tuple in the reference table, you also delete all the tuples that are referencing the tuple in the reference table, and then you delete all the tuples in the referencing table, okay, which are dependent on the tuple that is being deleted. That is cascading the delete action. Otherwise, the other strategy is you don't allow to do it. Otherwise, you set it to some default value. That means when you delete some tuple in the R2, and then if it is being referenced by some other tuple in R1, then in R1 for the tuple which is dependent on this tuple in R2 which you are going to delete, then set under that foreign key column the value, you can set it to some default value. That is possible. The next strategy is set to null, because in when I have a foreign key constraint, a value under a column can be null. It is possible, so we can set it to null. What if update on R2, R2's P, value of P is happening? Again, I can adopt the same strategies or adapt the same actions, that is cascade the update, don't allow at all, set it to default or set it to null. Let us try to understand these concepts with the help of a example. Again we will go back to our old example, that is employee and department. Here D number is the foreign key which is pointing to the denum of the primary key. As of now there is no violation about the foreign key constraint. This is the relation instance for employee, this is the relational instance for department relation, there is no problem. And let us talk about first inserting a new tuple. If I insert a new tuple into this department table, is there any problem? There is no problem. I can insert something with 40 and I can give some name and then the location can be something, there is no problem. So there is no problem as far as this is concerned, that is the reference table is concerned. When I insert a new tuple, there is no problem. But when I insert a new tuple into this, that is the employee table, can I do like this, some name and then 42 and then can I have some 60 or something like this? No, it is not possible. When the tuple you are going to insert into the referencing table and the value is not there, not existent in the reference table, then what should I do? Don't allow this insertion, because it is clearly violating the referential integrity constraint. Then you don't allow this insertion, so not possible. Then delete operation. If I am deleting some tuple in employee table, can I delete this tuple, that is 141 Ahmed, can I delete the tuple? There is no problem, because the dependency, if you look at the foreign key constraint, referential integrity constraint, the department is the parent table and then employee is the dependent table. The tuples in employee are dependent on tuples in department, not other way around. So that is why at any time I can delete any tuple in employee table, there is no problem. But if I try to delete, as far as delete operation is concerned, okay, insert operation is concerned, there is a problem here and then there is no problem here. Delete operation, I can delete a row here without any problem, but there is a problem. If I try to delete this row, what will happen? If I try to delete the HR, a row related to HR department, then what happens? If you carefully observe, there are two rows, that is this row and this row, which are dependent on this tuple in department table. Then what will happen to them? If this is not there, the value 20, it violates in referential integrity constraint, because the value 20 is not non-existent in the department table. It is a clear violation. So what should we do now? Then the first option is don't allow. Second option is cascade, meaning that what? Cascading means cascading, the effect means when you delete a row in parent table, you figure out all the dependent tuples and then you also delete them. According to this, I will be deleting the tuple for Ramu and then tuple for Ahmed. This is the cascading effect. The next option is set to default. Set to default. While defining the structure of the table, for any column, I can say that what could be the default value. So if you have the default value, when this particular row is deleted, I can set it to some default value, some 50 or something like this. So I can specify the default value. That is, don't allow, that is one option, cascade the effect, that is the second option, and then set to default, that is the third option. The last option is set to null. That means whenever I am deleting this, for this tuple and this tuple, what I can do? I can delete, I can set these values to null. Null value is also always possible in this, when we set referential integrity under the column foreign key column, the value could be null. So this is possible. This is how we should take care of this referential integrity constraints when we perform operations like delete, insert and then update. And similarly this is about delete. And then coming to the update operation, I cannot perform update operation freely on this table, because if you try to update this value to something else 60 or something like that, so it is going to clearly violate the referential integrity constraint. So what should be done? Again, you should be very careful about, you don't allow that, you don't allow this update operation on the referencing relation. If I am updating some tuple in the referenced relation, suppose if I want to make it to 40, then what should I do? If I change it to 40, the tuple in the referencing table, that is referring to this particular tuple, now the 30 is not available in the table. So, what should I do? Again the same thing. The first thing is you do not allow to do it, do not allow that update operation. Second thing is cascade the effect. That means whenever I change this, I also automatically change the values under the foreign key column. That means by default this will also become 40. That is called as cascading the update action. That is all dependent tuples will also be updated. Cascading the delete option means all dependent tuples in the referencing table will also be deleted. And the next one is set it to default. That means set it to some default value, or otherwise set it to null. Null value is always possible, so set it to null. So, that is why I can perform insert, delete and then update operations on the tables by keeping the referential integrity constraint in mind, and then as and when the situation requires, we need to take appropriate step, either to allow, to cascade, or set to default or set to null. Coming to the summary of the discussion, we have learnt what are the basics of relational model, how to represent schemas, what is a relation instance, relational data constraints, what kind of constraints can be enforced on the relational data. We have domain level constraints, we have entity level constraints, we have referential integrity constraints, and we have seen what is the meaning of each of these constraints and what care need to be taken when we perform operations like insert, update, delete on the data available or stored in the relations. Then we have in detail we have discussed what is referential integrity constraint, how to set that, and then we have seen how to represent relational schemas diagrammatically, and then also seen how to indicate the foreign key constraints diagrammatically, how it can be represented, that also we have seen. Thank you very much.